only our data coach intern. We'll talk about deep learning and neural networks and their effects on the medical and financial sectors. I will kindly ask you to mute your mic so we can hear Jasper clearly. And if you have any questions, please leave them in the chat and Jasper will answer them after the presentation.
Yes.
Finally, I want to let you know that this meetup is recorded. Hope you enjoy this session. Jasper, platform is yours.
Yes, thank you. Okay, so is everybody able to see my screen?
Yeah, I can see it.
Okay, so today I want to talk about deep learning. So what is it? How will it revolutionize the industry as we know today? So what are some implementations of it, and how is it used in businesses today, and how can it be implemented in the future? So this is me. I am Jasper. I am 20 years old right now. I live in Rotterdam, and I'm an intern at the Do Good Only company. And you can find me on LinkedIn and GitHub. So at first, I want to give a brief overview about what I'm going to talk about. So I'll talk about the meaning of deep learning. So what is it? I want to redefine what it is. And then I want to define a neural network, because without a neural network, we don't have deep learning. And then we are covering the question, are we moving to a new era? So is this a new era, or are we already in this era? We might not know yet. So how can this deep learning influence the medical world? So is it already implemented, or are new technologies still viable to use? And is it applicable to real business cases, like medical business cases? So we will also talk briefly about that. And one of my favorite topics actually is like, how can we use this technology in finance? So for example, prediction in forward in time. So for example, stock market predictions and other predictions like house market prices. So basically market predictions. And I want to say to you, if you have questions, you can just leave them in the chat. Any technical questions I will answer at the end, because otherwise it will take too long to cover everything. So please leave them in the chat and I will go over them in the last section, which is a Q&A. So I want to define what deep learning is. So what is deep learning? So we all heard about the terms artificial intelligence, machine learning, and maybe some of you even heard of deep learning. So what is deep learning actually? So deep learning is a way to solve a problem, but the computer really learns stuff. So what we are trying to recreate is we try to recreate the human brains inside of a computer. So we are able to learn to solve a problem, not really solve a problem by using simple algorithms with calculations, but by really solving them by learning stuff itself, just like we do in our brains. So what is a neural network? How do we define it? So in our brains, we have all brain cells like axons and dendrites. I don't know if any of you are familiar with these topics. But basically what's happening is an electrical signal goes to one of your brain cells and goes into many different other brain cells. And all these connections combined is what's called a neural network. So what we have is like we have our inputs, like from our 5 senses. So our eyes, touch, feeling, smell, and everything like that. So our 5 senses are our inputs. And our inputs, our brain makes sense of those inputs and we get an output. So for example, if I think that I want to touch this bottle, for example, my body will do it because that's the output which I learned. So the computer also can learn these cases. So it's able to learn basically the same way as we are doing. So that's what is the powerful thing about neural networks. It can really learn to solve something, and sometimes even without knowing what to actually solve. So it can solve things we might not have think about yet. So the real question then becomes, because of this powerful technology, are we moving to a new era? And I think a better question to ask in this is, are we not already in a new era for artificial intelligence? Because nowadays we see so many use cases of AI. For example, when you try to unlock your phone with your face, it's also AI. It's called face detection, and it uses also the same principles which I talked about before. So it uses these deep learning techniques to really learn to identify your face, and just the same way as we can identify other faces. So it is really powerful that we have these tools nowadays, and we have now the computationally power to calculate this stuff. Because why isn't this used earlier in history? Is because we didn't have enough computing power to calculate all these complex calculations. So nowadays we can do it because we have really good graphical cards, and we can do these calculations really quickly. So back to the topic of, are we moving to a new era? So like, as you might have noticed, Tesla, for example, is like a really big company for cars, for car manufacturing, but they are also trying to work on cars that are self-driving. So we might even in the future see cars that don't need a wheel or something like that. So we can, these cars can ride by themselves, and this is a really good thing, because it might even in the future, if it is really developed really good, solve the issue that there are not so much crashes with cars and no more issues with just like crashes and stuff like that. So it's really powerful. And in the medical world, I will talk about it a little bit on later, we can also identify like problems with these deep neural networks. We can see things that we humans didn't think about, or we need experts to solve these issues. And I will talk on the subject right now. So as you might have known, when you have an issue, you go to the doctor. He's a professional, and you might even get referred to some expert who is going to look at your problem. But what if this problem can also be solved by an AI? Would it be possible? And this is like a big question which is asked nowadays, because we can improve the medical world drastically by using these deep learning techniques. So for example, when I go to the doctor and I have like a tumor or something like that, and he doesn't know how to identify it, so we are making a picture of it with like MRI scans and stuff like that, and then when the doctor tries to see, hey, is this a tumor, yes or no? And he might not even know it, but when you have an AI model trained to really look at these tumors and solve the way and look at the way these tumors are labeled, so it looks at previous data of these tumors, and it trains itself to learn to identify what is a tumor and what is not a tumor. So based on these deep learning models, we can see if this is a tumor or not, which experts might not even see by at first glance. But these models can see this greatly complex patterns, which is a tumor, by learning to identify it, by training itself. So this is what the power of this is. And I will also show you a use case which I made in the medical world to solve an issue in the medical world. So this is called the mechanism of action prediction. So what it is we have like brain cells, we have cells in our body, and we want to see, based on the activities of these cells, what drugs someone has used. So they measured, like, you have like your cells, and they go in with a microscope and look like a few hundred different actions that a cell can produce. And they do it with tests at the laboratory of MIT and Harvard. So based on these cell movements and the way these cells are operating, we can look about, hey, what medicine did this person use? And I will show you how I solved this problem, because I actually, this is a publicly available data set on Kaggle, and I competed in this competition. So I will show you what I did to solve this problem. Okay, so what I did is I imported, for anyone that is not really technical or doesn't follow through, you can just ask any questions about what it is, but I will give a brief overview about what I did here. So I won't go into too much detail, because otherwise I can be talking for like a few more hours, but I will go over it really briefly. So I find the data, I load it in. So this is the data for like all the cells and all the medicines that are used in a data set. So it's a labeled data set, so we can see on what actions made based on what actions which medicine did someone use. So we have a whole data set. So we load in the data set, we get some insights in the data set about what we need to look at and what is highly correlated, so which actions are really good correlated with each other, check if there are any missing values in the data set. And then, yeah, we can here see that we are checking for the correlations between the movements. So we can see that the movement C5, C55 and C11 have high correlation. So probably these two actions are highly correlated. So the model will try to pick those one up because those one are, these values are really likely to give a better prediction about which medicine is used. And we also look at which medicines are somewhat like each other by using a correlation. And then we pre-process the data. So we split the cell observations and the medicines. So we have two different data sets, so to say. So we have a training and a test data set. And the training data set, we will check, we will train the model so it learns to recognize these patterns. And in the test data set, we will just run it through the model and see what the performance was. So how many good predictions did it make? So we set up the hyperparameters for our neural network. We then create our neural network. We build it, so we identify before we run the model what mathematical optimization functions we are trying to use to optimize these problems. And then we do the execution. And as you can see, the model is learning right now. And as you can see, the accuracy, so the way how good it predicts actually goes up in the time of training. And the loss goes down. So this means that the model is really learning at this point. So at this point, the model is learning to see based on what movements a cell made, what medicine belongs to it. And since this was a competition, you had to submit the competition. So I submitted it, and the most important part is the loss. So how much did you get correct? And I submitted it, and I got like a pretty good prediction at first. And then other people got better and better models than me because I didn't really trying to optimize this problem. So they passed me really greatly. So I wasn't really that high in the competition. At first I was, but then other people tried to optimize the problem and they got a lot better. So that's what a medical issue is, which a deep learning practitioner can solve. Oh, let me quickly go through this. So now we will talk about what influences deep learning has on the financial world. So for example, Wall Street, for traders and stuff like that, because this is also like the biggest market that we know nowadays in the world, like all the stock markets where all the investors can buy stocks for companies and sell stocks and make sure they help companies out when they needed it, for example. So we can say, is this old way everybody traded without these deep learning models still viable? So are they not getting outcompeted by these models? Because normally these people use their own matrices to look at the data and see if this is a good decision to make on the data, to buy or to sell. So does a machine learning model get it better? We might not know it. So how do experts trade nowadays? So what they do is they get their financial advisors, they look at matrices and they try to diversify or predict if the price goes up or down. So that's simply said what they do nowadays. But the question is, can deep learning do this better than those experts in these fields? And I get to some papers. I saw one really big investor, which is called Ray Dalio. He is one of the biggest hedge funds manager in the world. He has like 20 or 30 billion in assets. So it's a big player in this field, and he makes all his decisions based on his AI predictions. So he lets this AI predict for him what the stock market, and he's going to base his own decision based on these models. So he doesn't do it all by himself. So he tries to use these really deep learning models into its advantage. And we also have another really big asset manager I wrote about is Marcos Lopez, and he is one of the biggest quantitative trader, it's called. It's like financial machine learning, basically. And he has also around 20 million in assets. So he also, 20 billion, I mean, in assets. So he tries to optimize performance for really big investors. So he also uses machine learning in order to optimize his profits. So I will give you a demo about how to tackle this and what to do when you try to predict the stock market. So what people use nowadays, or maybe back in the days, are like simple algorithms like moving averages to try to predict the trends, to see if the stock is going up or down, or they use also linear regression and other matrices to evaluate if their model is any good. So how can we do this by using deep learning? I will give a brief overview on how I should tackle this, or how I would tackle this problem. I wouldn't say this is the correct way, but this is how I would solve this problem. So what I would do at first is I would look from, hey, where do I get this financial data? So the financial data, I get it from a Yahoo Finance stock screener API. So I can load in all the stock history prices into my Python file. What I then try to do is to look if any missing values or any data cleanup needs to be done. And if everything in that case is correct, I would create a window time frame data set. So what I can look at is about a specific time frame and look one step in the future, and do that from all different time steps in the data. So when I use this model, I can do many predictions on the data for my system. So it can do multiple tests, so to say, to optimize my model. So I have this window data, and I want to feed this also into my neural network, because a neural network can learn really high complex patterns on this data, even patterns that are beyond our imagination. So if you have a fully optimized model and you give it the data, it will always find the most optimal way to find the solution for that data. So for example, I want to predict if it goes up or down. So if I give it clean data and I have the optimal model, it will always find the optimal way of predicting. So there is no better way based on that data to make a prediction. So then the question is, what data should we feed in? And this is actually the hardest question, about what data should we give this model to make stock predictions. So that's one big thing to think about. And as you can see, when you train the model and you try to make predictions, it will look something like this. And we can also forecast this into the future and see what the next prices will be. So like this, we can see the predictions from the close prices. So this was it for now. So I'm curious if there are any questions, if something wasn't clear for you, or if you want to know something more about the topic, just ask me. Oh, there are no questions? Okay.
I guess everything was clear.
Okay.
Guys, if you have any questions, you can just unmute yourselves or type in the chat. That's also fine.
Jasper, I have a question
Yes.
for you.
Yes.
How much compute power is required to process these models on the scale? Do you know, like the financial services and healthcare? What are we talking? What does that infrastructure look like?
So what it is it also depends on how much data you are trying to feed into it and how complex your model is. If you have like a really, really complex model and you have like a really big data set you want to try to predict, then it would take a really long time to make all these computations, especially, for example, in stock market predictions, because you want to get your evaluation fairly quick. So what you then can do is like distributed training. So you train on multiple GPUs or use some better hardware than you now have. So you can do cloud computing in order to make quicker predictions on those models.
So is that like the same? Do you think that that's the same model that like there's the Flitz traders are using? So like the super fast, because it's transactions per second, right? It makes a huge difference on whether you pay too much or too little. And when you're talking about millions of euros, dollars, pounds, whatever, people aren't very patient. How do you see? How does that translate then with, like, if you look at, I know in Amsterdam there's a company, there's lots of, they call them Flitz traders, and they're all at supercomputing speeds with the models and the data that they're consuming.
Yeah.
Where are they getting all of that data from? Is it generated? Where is it? Do you know? Have you seen any information about that? Because data costs, right? Data costs to store, to acquire.
That's true. So if you want to have more frequent data, then you should use like paid APIs. So these are like the big companies who make sure the stock market goes as it works. They also have APIs which you can use to get immediately updates for the stock market prediction, but it also get at a high cost the quicker you want to get your API. So you actually pay really a lot to get this data coming quickly. But it also depends on what kind of trader you are, because you can also make models with trades around the day and not like trades per seconds, for example, because you can use these models, and I think these are the best ones, the trades per second models, but you can also use lower frequency trading models. So it depends on what time window you select in your model, which I talked about, like the time window you choose. If you choose a bigger time window, then you can make predictions on longer times, so not for like transactions per minute. So I think for not big investors, it's like a good idea to have like these models, not like trades per seconds, but maybe trades per minutes or stuff like that. So the delay doesn't really matter that much, so to say.
And then what would be your advice for an individual that wanted to invest using the data that's available in machine learning and everything else?
In my opinion, for now, because I'm not an expert in this field, I have little knowledge, but what I should do is like, I would still, because models are really nice and how they work are really nice, but it's like a really tricky question, because you don't know if the model you feed into it is really good. It can be sell high and the closing price, for example, but is this enough data to make a good prediction? And that's what the question is. So I think what I should do is like, I would, if I would trade with AI, I would try to forecast it into the future. So I want to see it for example, next week or something like that, or next month. So on a not on a trade per second, but on a longer time period. So I can make my own decision based on other information I can get on the internet and on other matrices, which I know, to make this trading decision. So not truly depend on this AI model, but use it as an advisor for you to make sure you make a good prediction.
Cool, thank you.
Yes. Any other questions?
Yes, I have a question. My name is Zobran. What is the difference between machine learning and deep learning?
So what the difference is between machine learning and deep learning is they're actually the same things, but like deep learning goes one layer deeper. So what machine learning is like algorithms to optimize a problem. So you try to figure out, you have a problem, and you try to find a way to optimize to find a solution. And it's also what deep learning does. So in that sense, they are the same thing. But the way deep learning works is like deep learning uses the implementation of the brain. So it learns by itself. So it kind of try to recreate the brain. And machine learning doesn't do that in its own without deep learning. So that's the difference.
Okay, thank you.
No problem. Any other questions? No. Then I want to say thank you to everybody who listened to this, and please make sure I put my socials down. If you want to follow me or have any questions, you can just still ask me on one of these platforms, and I will try to answer it. And this was it. Thank you for listening.
Yes, thank you, Jasper, and thank you everyone for joining today's session. As I said, this was our last meetup. We'll start over in January. If you have any topics that you want to discuss, we can give you our platform and you can do your own meetup. Meanwhile, I want to ask you to fill out a survey. It's like very short survey, 2 minutes it only takes from your time, and we'll use that to improve our meetups as a feedback. And I wish you a happy holidays, stay healthy, and hope to see you in January.
Yes.
Bye, everyone. Bye,
Bye-bye.
Jasper. Thank you.
Bye.
Bye.